Hello everyone. Now we are starting your unit 5, that is introduction to transport layer. The transport layer is the core of the internet model. The application layer program interact with each other using the services of the transport layer. Transport layer provides the service to the application layer and takes the services from the network layer. The transport layer is the fifth layer in the internet model. The transport and the it is the fourth layer of the open system interconnection, that is OSI model, and it is responsible for end-to-end communication over the network. It provides the logical communication between the application processes running on the different hosts within the layered architecture of the protocol and other network components. Next is duties of the transport layer. Transport layer is mean for the process to process delivery, and it is achieved by performing a number of functions. The basic duties of the transport layer is the packetization, connection control, addressing, flow control, and error control. That is covered under the providing reliability. So first is packetizing. The transport layer creates the packet with the help of encapsulation on the messages received from the application layer. Packetization is the process of dividing long message into the smaller ones. These packets are then encapsulated in the data field of the transport layer packets. The header containing source and destination addresses are then added. The length of the messages which is to be divided can vary from several lines, email to the several pages, but the size of the message can become a problem. The message size can be larger than the maximum size that can be handled by the lower layer protocols. Hence, the message must be divided into smaller sections. Each small section is then encapsulated into the separate packet. Then the header is added to each packet and to allow the transport layer to perform its other functions. Next is connection control. Transport layer protocols are divided into two categories: connection oriented and connectionless. So first is connection oriented delivery. A connection oriented transport layer protocol establishes a connection that is virtual path between the sender and receiver. This is a virtual connection. The packet may travel out of the order. The packets are numbered consecutively and communication is the bidirectional. And second is connectionless delivery. A connectionless transport protocol will treat each packet independently. There is no connection between them. Each packet can take its own different route. Third is addressing. The client needs the address of the remote computer it wants to communicate with. Such a remote computer has a unique address so that it can be distinguished from all other computers. Next is providing reliability. For high reliability, the flow control and the error control should be incorporated. So first is flow control. We know the data link layer can provide the flow control. Similarly, the transport layer also can provide the flow control, but this flow control is performed end to end and not across the single link. And last is error control. The transport layer can provide error control as well, but the error control at the transport layer is performed end to end and not across the single link. Error correction is generally achieved by the retransmission of the packets that discarded due to the error. Next is conjunction control and quality of the service. The conjunction can take place in the data link network or the transport layer, but the effect of the conjunction is generally evident in the transport layer. Quality of the service, that is QoS, can be implemented in other layer, but its actually effect is felt in the transport layer. The transport layer enhances the quality of service provided by the network layer. The transport service may allow the user to specify the preferred, acceptable, and minimum values of various service parameters at the time of setting up a connection. The typical quality of service parameters for transport layers are connection establishment and delay, connection establishment failure probability, throughput, transit delay, protection, residual error ratio, priority, and resilience. Next point is process to process delivery. The data link layer performs a node to node delivery. The network is carried out the datagram delivery between two hosts, host to host delivery. But the real communication takes place between two process or the application programs, which we needs the process to process delivery. The transport layer takes care of this process to process delivery in the packet from one process is delivered to the other process. The relationship between the communication process in the client server relationship is demonstrated into three processes in the figure. In this, multiple processes are running into the computer, and that are process to process delivery is shown in the figure. Node to node delivery is performed in the data link layer. Host to host delivery is performed in the network layer, and process to process delivery is performed in the transport layer. Next is client server paradigm. There are several ways of achieving process to process communication, but the most of the common method is using the client server paradigm. Client is defined as a process on the local host. It needs the services from the other process called as a server, which is on the other or the remote host. Both client and server have the same name. Some of the important terms related to the client server paradigm are local host, remote host, local process, and remote process. Although there are several ways to achieve process to process communication, most common one is the through the client server paradigm. A process on the local host called as a client need to service from the process, usually remote host, called as a server. As I told you, both processes, that are client process and server processes, have the same name. For example, to get the day and time from the remote machine, we need the daytime client process running on the local host and daytime server process running on the remote machine, that is your server host. Next is addressing in the transport layer. The addressing requirement at the different layer are the different. At the data link layer, we need a MAC address. At the network layer, we need to use an IP address. At the datagram, uses the destination IP address to deliver the datagram and use the source IP address for the destination reply. At the transport layer, a transport layer address is called as a port number is required to use to choose among multiple processes running on the destination host. The destination port number is required to make the packet delivery, and the source port number is needed to return back and reply. In the internet model, the port numbers are 16-bit integer. Hence, the number of possible port numbers will be 2 raised to 16, that is 65,535, and the port number ranges from 0 to 65,535. The client program identifies itself with a port number which is chosen randomly. This number is called as a ephemeral port number. The server process should also identify itself with the port number, but the port number cannot be chosen randomly. The internet uses the universal port number for server, and these numbers are called as a well-known port numbers. Every client process knows the well-known port number of the pre-identified the server process. For example, a daytime client process can use an ephemeral temporary port number 43,000 for identifying itself. The daytime server process must be well-known permanent port number, that is 15 port number. Now, in this diagram, we are showing the TL addressing port number to choose among multiple processes running on the destination, local host process and remote host process. To define that, we are using 13 port number of the server, that is permanent port number, and 52,000 port number, that is client port number, that is temporary port number. Next is, what is the basic difference between the IP address and port number now? So the IP address and port numbers have altogether different roles in the selecting the final destination of the data. Destination of the IP address is used for the defining that particular host among the millions of the hosts in the world. After the particular host is selected, the port number is used to identify one of the process that is selected on this host. Next is INA ranges. INA is International Assigned Number Authority. The port numbers are divided into three ranges by the INA. The three ranges are well-known ports, registered ports, and dynamic or the private ports. So first is well-known port. The ports from 0 to 1023 are known as the well-known ports. They are assigned as well as controlled by the INA. The INA is International Assigned Numbers Authority. It is the standard organization that oversees the global IP address allocation, autonomous system number allocation, root zone management in the domain name system, that is DNS. What is DNS we'll see in the next chapter. Media types and other internet related symbols and internet numbers. Second types of ports are registered ports. The ports from 1024 to 49151 are neither controlled or assigned by the INA. We can only register them with the INA to avoid the duplication. That are user defined port numbers. Third are dynamic or the private ports. The ports from 49,152 to 63,535 or the rest of the ports are known as the dynamic ports, and they are neither controlled nor registered. They can be used by any process. Dynamic ports are also known as the private ports, and the dynamic ports are called as the ephemeral ports. Next is the socket address. Process to process delivery, that is transport layer communication, has to use two address. One is IP address and the other one is the port number at each end to make a connection. Hence the process to process delivery uses the combination of these two. The combination of IP address and port number is shown in the figure, and it is known as the socket address. The client socket address defines the client process uniquely, whereas the server socket address defines the server process uniquely. The transport layer protocol requires the client socket address as well as server socket address. These two address contains 4 pieces. This 4 pieces goes into the IP header and the transport layer protocol header. The IP header contains the IP address while UDP and TCP headers contains the port numbers. The combination of the IP address and port number is called as a socket address. As I told you, the client socket address defines the client processes, and server socket address defines the server process uniquely, and that already I have told you in the given example. 200.23.56.8 is the basic IP address and port number is the 69, that is used for the communication between two transport layer communication. Thank you.